Dalton's atomic theory. In 1803, Dalton developed the atomic theory. The four main points, that is assumptions, of Dalton's atomic theory are summarized as follows. 1. Matter is made up of tiny particles called atoms. The word atom means unsplittable in Greek. 2. Atoms can neither be created nor destroyed. 3. Atoms of the same element are identical and have the same mass and properties. Atoms of a given element are different from those of any other element. Atoms of different elements can be distinguished from one another by their respective relative weights. 4. Compounds are formed by a combination of two or more different kinds of atoms. Atoms always combine in simple whole number ratios. Dalton never imagined that anyone would ever be able to see an atom. However, modern technology has provided direct evidence that shows the positions and patterns of individual atoms. The use of modern technology has enabled scientists to carry out experiments on the atom that Dalton could not. This has led to slight modifications to Dalton's atomic theory and thus formulated the so-called modern concepts of Dalton's atomic theory. These modifications include the following. 1. Atoms can be either created or destroyed by means of nuclear reactions. The atom can change form through special processes such as nuclear fusion, that is combining the atomic nuclei, or nuclear fission, that is splitting the atomic nucleus. For example, an atom of uranium-235 can be split into two separate atoms. 2. Some elements have atoms of more than one kind which differ slightly in mass. Such atoms are called isotopes. For example, carbon has three isotopes known as carbon-12, carbon-13, and carbon-14. 3. An atom is made up of smaller subatomic particles called protons, neutrons, and electrons. 4. Atoms of different elements may chemically combine in many different ratios to form compounds. The modern atomic theory builds on Dalton's original ideas by recognizing subatomic particles, isotopes, and nuclear reactions while retaining the ideas of chemical combinations and reactions. Dalton's discovery thus helped the scientists understand chemical reactions and how substances combine. Subatomic particles. In 1897, J.J. Thomson carried out experiments and described an atom as a sphere of positive charge, with negative particles called electrons spread throughout the sphere. This model of the atom was referred to as plum pudding model, as shown in the figure displayed. Thomson, therefore, managed to discover the electron among the three subatomic particles. His discovery led to the inventions of electronic devices such as televisions, radios, and computers. However, another scientist, Ernest Rutherford, reasoned that if Thomson's model were correct, the atom's mass would be evenly distributed throughout it. He conducted experiments and discovered that most of an atom's mass is concentrated in its nucleus, that is the central core. Within the nucleus, there are positive charged particles called protons. This was the second subatomic particle to be discovered. Rutherford's discovery helped the scientists discover nuclear energy used to produce electricity and in radiotherapy. Rutherford's findings are summarized as follows. 1. Protons, the positively charged particles of an atom, are located in the nucleus. 2. Most of the mass of the atom is located in the nucleus. 3. The nucleus has a relatively smaller volume compared to the whole atom. 4. Electrons have very small masses compared to the protons. 5. Most of the space in an atom is empty. 6. Electrons are the negatively charged particles in an atom. They move around the nucleus in orbits. Rutherford thus developed the planetary model of the atom shown in the figure displayed. In 1932, a scientist named James Chadwick discovered neutrons, which also form part of the nucleus. The figure displayed shows the locations of neutrons and other subatomic particles in an atom. Neutrons have the same mass as protons but no charge. They are located in the nucleus of an atom. They were the third subatomic particles to be discovered. The Chadwick discoveries have made nuclear power possible, helping to produce electricity and develop medical treatments such as cancer therapy. The properties of neutrons are summarized as follows. 1. They have no charge. That is, they are neutral. 2. They have nearly the same mass as the corresponding protons. 3. They have a mass nearly 1,840 times that of an electron.